Imagine you're in a science lab sorting living things, mammals, birds, reptiles. Each category is a set. But what set do all of them belong to? That's the universal set, the complete group of all living organisms you're considering. In mathematics, the universal set, denoted by the letter U, is the set that contains all elements relevant to a particular discussion or problem. The most important point is the universal set depends on context. For example, if you're dealing with numbers, you might be the set of all real numbers in a school problem. You could be all students in the school in geometry. You might be all triangles in a plane. What qualifies as universal changes depending on the topic or situation. Let's look at a few more examples. Say set A is brace 2, 4, 6 and set B is brace 1, 3, 5. Then universal set U would be brace 1, 2, 3, 4, 5, 6. Both A and B are subsets of U. In geometry, if U is the set of all two-dimensional shapes, then a subset might be all circles. In literature, if U is all Shakespearean plays, a subset could be his tragedies. In a Venn diagram, the universal set is drawn as a large rectangle. The sets being studied, like A, B, or C, are drawn as circles inside the rectangle. Elements outside the circles but inside the rectangle belong to the universal set, but not to those specific sets. This is helpful when studying complements and set differences. The universal set plays a key role in understanding complements. If A is a subset of U, then the complement of A, written as A prime or A dash, includes all elements in U that are not in A. In set builder form, we write a prime equals brace X such that X belongs to U and X does not belong to A close brace. This forms the foundation of important laws, like De Morgan's laws. The universal set gives us a defined boundary, a frame within which all set operations take place. It's like setting the stage before a play. Whether you're working with Venn diagrams, probability, complements, or logic, everything relates back to U. Understanding U ensures that operations like union, intersection, and complement are interpreted with clarity and precision.